Hi everyone, welcome to Number System Class 2. My name is Prashant Mohan Thakur, and this is your own educational YouTube channel, Competition Valley. So in previous class, we did some questions based on some topics based on rational numbers, and we tried finding out the definition of rational, irrational, and we also got to know why rational numbers are rational number and why do we call irrational number and irrational number. Today, we'll be working with some different concepts, and we'll try to see their applications as well. So when we were doing the number line in our previous class, we studied something about prime number. So we'll start with prime numbers today. So prime numbers are of very unique feature. They have only two factors. One is the number 1 and the second is number itself. Now also remember that number 1 is not a prime. 2 is a prime number, and also remember 0, we have studied this before as well, just I'm giving a brush up. 0 does not get included in natural number. Very important because there are lots of questions that you will find with such themes. So it's very important to remember all of these things anytime. So now, just by looking itself, let's say we have a number 36241771995. How do we say if this is a prime or not? Okay, so we'll start with, there are so many ways by which we can decide, we can check if the number provided is prime or not. So we'll get to all of these one by one. So first of all, let us see some observation over here. Let's observe something. So let's take number 36 over here. We can take 42, 45, and 100. Okay, odd, even, perfect square. I've taken all sort of number over here. So if you look at 36, look at the factors: 1, 2, 3, 4, 6, 9, 12, 18, and 36. With 42, 1, 2, 3, 7, 21, we have skipped 6. Yeah. So 1, 2, 3, 6, 7, 14, 21, 42. With 45, 1, 3, 5, 9, 15, and 45. With 10, 1, 2, 5, 10, 20, 25, 50, and 100. I'll check if it is right or not later on. So now, what have to we observe? Let's say this is n equal to 36, and we want to check if this is a prime or not. So what we can do, we can simply square root n. So we get 6, and we can see if all the numbers before the square root of the given number, if any of these number divides n or not. Now why do we do that? Why don't we just keep dividing all the numbers? Because with all the numbers, there's a basic characteristic that the number of factors that each number would have before its square root and after would be equal. So over here, 36 square root is 6. We have 4 factors before, 4 factors after that. Similar with 42. So let's n is here. So if we square root n, we get 42. So it will be somewhere near between 6 and 7. So what we can check, let's say over here is the square root. So you will see there are equal number of factors before and after. It will be same with 45 as well. If we take n over here and if we square root n, it will be nearby 6.8, I believe, because 7, 7, 49, 6, 6, 36. So let's say it would be again between 5 and 9 somewhere. So you will see 3 factors before that, 3 factors. Now with over here as well, we'll see the same thing over here. There would be no difference. Square root of this number, if we take this as n, so square root of n would have equal factors before it and equal factors after. So what we can generalize from here is for a given number n, we can check if it's prime or not by checking with all the prime numbers before square root of n, or we may call it as small n. Okay, so once again, this is a very important term over here, which is checking with all the prime number only. For an example, you want to see if let's say if 47 is prime or not. Okay, so we know that square root of 47 is very close to 49, so it should be around 7.8. So what we need to do, we need to check with all the numbers which should be equal to 7 or less than. So for all the numbers which should be equal to or less than 7. Okay, sorry, it should be here. So we do 47 square root, we get something around 7.8. So we start checking with 7, then we check with 6, then we, not 6, 5. Then we check with 3, 2, and 1 is not a prime, so we need not to check from there. Okay, I'll elaborate this concept again. Just a second, we'll rub this off. Now, let's, for an example, see if 143 is a prime or not. We need to check this. So what we do, n is 143. So what the first step that we do is square root n, or square root 143. So we know that it's closer to 144, and 12 is a square root, so it should be around 11.9. So what we are going to do, we'll check for all the numbers which are less than or equal to 11. So we start with 11, so we see 11, 1, 11, and it is 11 into 13. So straight away we get to know that it is not a prime. Again, we can do for some more. We can take any number. Let's say we can take for 627. So this is n. We need to see if it is a prime or not. So what we do, first of all, we square root this. So we know 25 is around 625. So it should be around 25.1. So what we can do, we can check for all the prime numbers, all the prime numbers before 25. Now you see there's a difference over here, that I have given an equal to sign over here, but I have not given over here, because this is again a prime number. Even if you go equal to sign, we cannot do it, because what is the condition, that all the numbers that we have to check the divisibility has to be a prime number, which 25 is not. That's the reason for it. Okay, so don't get confused over here, not at all. So we start checking it with, we can check with 3. You can start other way as well. You can see with 3 to 6, and you see it divides 3, so it is not a prime. So this is one of the way wherein you can just square root it, and you can, from square rooting it, you can get to know if it is a prime or not. This is one of the way. There are so many other ways as well. We'll be discussing it one by one. So now this was one of the methods. Now the second method, we can check it. The second method would be to check by, hang on. The second method. So what we can do in the second method is we can check, we can add up the, let's say there's a number, for an example, 527632589, whatever these numbers are. Now we need to check if prime or not. So what we can do is we can add up the sum of over here. So 5 plus 2 plus 7 plus 6 plus 3 plus 2 plus 5 plus 8 plus 9. So if we add up 5 to 7, 7, 14, 6, 20, 23, 25, 30, 38, and 9 is 47. 47 is 4 plus 7 equal to 11. And when we add 11, it's 1 plus 1 equal to 2. So 2. So the digital sum, this is called digital sum because we're adding up all the digits. So digital sum, so remember that digital sum of a prime number can never be 3, 6, or 9. Let me show you with some examples. Let's say, for an example, we can consider 1, or we can consider, let's say, 59. 59 is a prime number, so if we add it, 5 plus 9 is 14. It's going to be 1 plus 4 equal to 5. So digital sum is adding up all the digits of a number. We can take on any other example. Let's say 129. 129 gets divided by 3, so we can take 131. Okay, so 131 is 1 plus 3 plus 1 equal to 5. So it can never be. Now let me show you. Let me show you some non-prime number. Okay, or let me take any random example again. That will help us. If you want to check for 3, 8, 7, 6, 2, 4, 1, 9, 1, 8, 5. That's it. So we can check the digital sum. 3 plus 8 plus 7 plus 6 plus 2 plus 4 plus 1 plus 9 plus 1 plus 8 plus 5. So 3 plus 8, 11, 7, 18, 24, 26, 30, 31, 40, 41, 49, and 49 plus 5, 54. So 5 plus 4 is 9. So you can be very sure that this number is not a prime number, because it can never end over here. So that's the second way to determine. But yeah, the one thing you need to ensure, and that if, let's say, if it is not, let's say if it is ending on 5, it does not necessarily mean that it is a prime. The other way is not true. What I mean to say is, let's say digital sum of a prime number can never be 3, 6, or 9. But if the digital sum is coming 8, that does not give us a guarantee that it's a prime number. Okay, let's say for an example, we can take 44. So the digital sum is 4 plus 4 is equal to 8. But that does not, it's not 3, 6, or 9, but it does not mean that it's a prime number itself. It's just one of the way. You can be partial sure about this when you have a situation. So it's just like a situationary weapon that you have, okay, that you can go about this. If generally don't get such long numbers, but it's just a partial method. It does not give you a guarantee that if a digital sum is not 3, 6, or 9, the number is 100% for sure that it's a prime number. No, there's no such thing as such. So please don't get confused yourself all at all. Now, there's one more very interesting concept over here, that all the prime numbers would satisfy this condition. For sure, any prime number, be it P, it will, if just you can leave 2 and 3. Rest all the prime number. We can take for 5. So let's say when we take for 5, it's 5 square minus 1, which is 25, or it is 24 into 1, where K is 1. We can take for any other number. We can look for 11. 11 square minus 1 is 120, or it's 24 into 5. So this is one another way wherein you can be 100% sure that P square. You can take 17. So it's 17 square minus 1 is equal to 288, or 24 into 12, where K is equal to 12. So it has to be a multiple of 12, all the prime numbers. So this is one way wherein you can be 100% sure. In the previous method, you were not, but over here you can be 100% sure about this, that it is 100% sure that this would be followed. Okay, so now we'll go for there's another. Okay, let me do this way. So let's take three numbers: 5, 15, 19, 23, and 29. Okay, now let us try to express these numbers in form of 6. So if I do that, so I see this number is 6 into 1 minus 1. I see that 6 into 2 plus 3. I can be very sure that 6 into 3 plus 1, this would be 6 into 4 minus 1, and this would be 6 into 5 minus 1. Okay, now there's a property that all the prime number would be of form 6k plus minus 1, but the reverse may not be true. Now, again, look over here. Look very carefully that reverse may not be true. So you can see this also fulfills the criteria that it is 6k plus, okay, it is 6k plus 3, I'm sorry. So we can take 6 to, hang on, 15 we have taken wrong, we can take 25 over here. This is 6, 4 plus 1, okay. This would be 6, 4 plus 1. So you can see over here that it has to fulfill this criteria. So wherein you can see prime numbers follow, but there are so many other numbers which would fall into this category, but that not be true as well. So the reverse may not be true, only the first part, that all the, if it's a prime number, so this is when you get long numbers. Let's say you are getting a number as long as anything, 1, 5, 7. So the best way is, because you can really cannot convert it into p square one format, or even you cannot get the square root out of it, or you cannot be sure by the digital sum. So what you can do, you can simply divide and try to see if what you're getting, if you're getting remainder as 1 or not. Now this might look terrible, long, and time taking as if now, but once we'll be doing the division video wherein we will be knowing how to divide in real quick time, so then it will be easier for you. But for the time being, just consider doing the long process method only. Okay, so these are some of the ways to check if the numbers are, so I'm just writing it again over here. The first method was, you can go ahead and if is the number n, you can just square root the number and see all the prime factors less than equal to n is divisible or not. That's a one way. Second way, you can always check the digital sum, because the digital sum would not be equal to 3, 6 to 9, but that's not 100% assurance that it is 100% sure that if any number has a digital sum in as 3, 6 or 9, that it would not be prime. But the other way is not true, that if it is coming 7 or 8, then it's assurance that it is a prime. Okay, so don't get confused over here. Third is p squared minus 1 is equal to 24k, which would be always true. And the last, what we did just minutes back over here, that 6k plus minus 1 reverse may not be true. So these are some of the things that you should, if you want, you can take a note of it. Otherwise, if you want, you can just practice it and it will be there for you always. So now let's do some questions and let's see how we can apply this over here. So let's say I'm writing the question for you. Let x be a 4 digit positive integer such that positive, sorry, over here, over here, positive integer such that the unit digit of x is a prime and the product of all the digits of x is also a prime. Okay, so we need to check for the solution. Now, once again, let's read the question. X is a 4-digit number, 4-digit positive integer such that the unit digit of x is a prime and the product of all the digit of x is also a prime. So by reading this question might look difficult, but it's as easy. It's not difficult at all. Just you need to stick to the basics. You know what are the characteristics of prime. If it's a prime number, either 1 or the number itself. Now x is a 4-digit number, let's say, okay, and the unit digit has to be prime, okay, and then there are 3. So what are the options to be over here? What are the options? So over here it can be 2, 3, 5 or 7. Remember, we cannot put 1 because 1 is not a prime. I'm repeating again and again, this 1 is not a prime. So x is a 4-digit number integer such that the unit digit of x is a prime. So unit digit prime. Now the product of all the digits is to be prime as well. Now let's for a moment assume 2 is a number and you want to multiply it with any number wherein you want the result to be as such. Okay, it's 2 over here and you want it to be multiplied with any number, but the product should be 2 itself. So how would you do about that? So you have to multiply it with 1. The same goes with if we put over 3 over here. So we want the product as 3 because these are prime numbers and this is what we need. Otherwise, the condition given would not be satisfied. So again, 1. If we put 5, then also 1. So what we can do? Can't we put over here 1, 1, and 1? Think for a moment. Now what we have? So if we have possible numbers, we can see over here what could be 1, 1, 1, 2, 1, 1, 1, 3, 1, 1, 1, 5, and 1, 1, 1, 7. Because all the unit, you can see in the unit term, we have prime. You can multiply 1 into 1 into 1 gives 2, 3 into 1 gives 3, gives 5, and gives 7. Look here. Look here and see if we have any confusion. If you want, I can redo the question again. X is a 4-digit number. The product of all the numbers, let's say A, B, C, D. D has to be prime, and A into B into C into D has to be prime as well. 2 conditions, both the conditions will be satisfied. Okay, so don't worry, this is just the beginning. Even if you have slight difficulty in understanding, or if you're unable to do it at the first shot, don't get upset. Just the beginning. Okay, we'll do lots of questions. We would have so many videos wherein we would just have these questions and we would be solving it without using a pen or without, just mentally. It would be all done mentally. Okay, so don't get upset. Do not dishearten yourself. Stay with me. You'll be fine. Now, I guess. Okay, there you go. The second. Now again, we'll be doing the second question as well. It would have the same thing over here. So let's see what we can do over here. Now, okay, the product of 2 prime number is between product. Let's say product 2 prime number is between 17 and 51, or we can mark it away the product X so that it looks good. If one of the prime number is greater than 2 but less than 6, and second prime then the product of x of 2 number is 17 and 51. So if the product of x of 2 prime number is between 17 and 51, if one of the prime number is greater than the 2 and the second prime number is greater than the number, so let's take 13 but less than 25. So what is x, or what is the product? That's the question over here. So think for a moment that the product of two prime number is between 17 and 51. If one of the numbers is greater than, one of the prime number is greater than 2 but less than 6, and the second prime number is greater than 13 and less than 25. So what is x? Just think for it. Think for a moment. Okay, just look at the question again. That the product of two prime numbers between 17 and, oh, this is a mistake away. It should be 17 to 55. I'm sorry. It is 55. The product of two prime number is between 17 and 55. One of the prime number is greater than 2. So if we look for answer, so one of the prime number is greater than 2 but less than 6. So what are the options? We have 3 and 5. And the other prime number is greater than 13 and less than 25. So we have 17, 19, and 23. Okay, so what would be the possible number? So it's very simple. It has to be less than 55. So the only number that fits is 51. Answer. It's no difficulty over here. It's pretty simple. Okay, again, you look, it has to be two prime. It's pretty plain, simple question. I don't think any explanation is needed over here. Even if you don't know the concept of prime number, still you can do it. Still you can do it. Let's do a couple more questions. Okay, so let me see. It should be question. There would be ample question. Then I'm just doing this to make sure that the concept is very much clear. Okay, so let's say consider 4 natural numbers. These are x, y, x plus y, and let's say x minus y. Now there are two statements given. So statement number 1, all 4 numbers are prime, and statement 2, the arithmetic mean of the numbers are greater than 4. So now we have to conclude something out of this over here. Okay, so which of the following statements, the question would be over here, that which of the following statements would be sufficient to determine the sum of 4 numbers. 4 numbers. Would it be statement 1, statement 2, both, or we can say none, or we can say either, or we can anything, whatever. So these are some of them. So let's do it. So 4 natural numbers, x, y. Now 4 numbers are prime. So 4 numbers are prime. Again, use logic over here and it should be fine. Okay, so what are the numbers we can take? We can take 2, 3, 5, 7. We can take x equal to 2. But if we take x is equal to 2, we see that over here there's something x minus y. Then x minus y would not be a prime, and that would be a big trouble for us. Then we cannot take x is equal to 2 over here. Now for a moment, let's take another number. So we can take, for an example, if we take this is going to be a problem. Okay, so what we can do in this case, let's try taking x equal to, okay, x equal to, we can try with 3. So if we take 3, x3, and we take y equal to 5. So still we have problems. So what we can do, we can take x is equal to 5, and we can take y equal to 2. This should solve the problem. So we have x equal to 5, y equal to 2, x plus y equals 7, or x minus y equals 3. And so we have these 4 numbers. Now the second term says that arithmetic mean of should be greater than 4. So arithmetic mean is nothing. Add all the numbers and divide it by the quantity. So 1, 2, 3, 4. We have 4 numbers. So we'll be adding up and dividing by 4. So 5 to 7, 7, 14, then 17 by 4, which is greater than 4. So second. So the question over here is, out of these two statements given, what statement would be just sufficient to determine the sum of 4 numbers? We can easily determine the sum of 4 numbers just by the statement 1, isn't it? Because we got it. Even if this was not given, we could still have found the sum just by the 4 number itself. Again, look over here. Check what I'm talking about. It said that all 4 numbers are prime, and this is what it gave: x, y, x plus y, x minus y. Okay, so in no other way, if we would have taken any combination, let's say we could have taken x is equal to 5, and we could have taken y equal to 7, so then this would not be a prime number. So any combination, if you try out of this, putting x into y, different combination we would put, we will not get the desired result at all. So this is the only combination that would suit the best, and that we have taken. So we are pretty sure that this is the number, and since this is the number, we could easily do the sum even without the second statement. So although statement 1 and 2 both are correct, but statement 1 would be sufficient for us to take that. Okay, so we'll do some more questions on prime number in coming video. In next video, we'll be continuing this. For the time being, let's stop over here, and we'll continue in the next video. We'll do some more questions, and then we'll get to our next topic as well. Okay, so once again, thank you so much for watching this video. Thank you for your time. My name is Prashant, and you are watching Competition